So guys, in today's video, we are going to crack the question. I repeat, we are going to crack the question which I have asked in my previous video. Another concept called as chemical properties of aldehydes and ketones. Chemical properties of aldehydes and ketones. Yes. So basically, in this chemical property, before going to the depth analysis of this chemical property, I would like to write the carbonyl structure. Of course, you can ask me, sir, we are dealing with aldehyde and ketone. Why do we need a carbonyl structure? For them, it's a kind information from me. Remember, both your aldehydes and ketones are belonging to that of your carbonyl compounds itself. That is, both are having the carbonyl group. So whatever the chemical properties we are going to study under this concept, it mainly depends upon the structure and the polarity which exists on those carbonyl group. So when I am writing the carbonyl group, how can I write? C double bond O is in this way. Alwa. So of course I know here I am having the two atoms. One is your carbon, another is your oxygen. So when I am talking about its electronegativity, I repeat, when I am talking about its electronegativity, I know that oxygen is more electronegative. I repeat, oxygen is more electronegative than that of carbon. By the definition of electronegativity, what will happen now? Of course, the shared pair of electrons will be more oriented towards that of your oxygen. So the structure you will be having in this way. That is, oxygen will be having a partial negative charge, whereas the carbon will be having a partial positive charge. Yes, so this concept is very much important in order to understand the chemical properties of the aldehydes and ketones which we are going to study today in this video under the topic called as nucleophilic addition reactions. Nucleophilic addition reactions. Of course, in my previous video, I have asked you a question. What is that? Where does the incoming nucleophile will attack the carbonyl group? I repeat, where does the incoming nucleophile will attack the carbonyl group? Of course, the answer lies within the structure. So when I am writing the structure, that is C, O minus and delta plus, of course we know that the nucleophile is an electron-rich species. So let me represent it with the negative sign. Since it is an electron-rich species, of course we know by the concept of magnetism, negative will be attracted towards the positive. So whatever the nucleophile is there, it is going to attack our carbonyl carbon. I repeat, so whatever the addition reactions we are going to study now onwards, mainly you have to remember the nucleophile is going to attack the carbonyl carbon. What is the reason? Of course, due to the higher electronegativity difference between oxygen and carbon, the carbon is having a partial positive charge. And of course, this partial positive charge is trying to attract the nucleophile, which is highly negative charge. So this is whatever the reaction we are going to study. It itself is called as what? Nucleophilic addition reaction. Please mark my words. The carbonyl groups, whenever they have been treated with a nucleophile, they will be giving you an addition product. Why I am saying it? Because you have seen elimination product, substituted product. This is what? It's an addition product where our nucleophile is getting added. I repeat, where our nucleophile is getting added without substituting any other atom. So it's not a substitution. Neither any of the atom is eliminated. Instead, what is happening? ಯಾವ ಸ್ಟ್ರಕ್ಚರ್ ಇತ್ತು ಆ ಸ್ಟ್ರಕ್ಚರ್ ರಿಟೈನ್ ಆಗಿರುತ್ತೆ. ಆ ಆಟಮ್ಸ್ ಎಲ್ಲ ಅಲ್ಲಲ್ಲೇ ಇರುತ್ತೆ. ಅದು ಏನಾಗಿರುತ್ತೆ? ಒಂದು ಎಕ್ಸ್ಟ್ರಾ ಆಟಮ್ ಆಡ್ ಆಗ್ತಾ ಉಂಟು. And ಆ ಎಕ್ಸ್ಟ್ರಾ ಒಂದು ಏನದು? ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್. It is adding. So the reaction is called as what? Nucleophilic addition reactions. I repeat, whenever the carbonyl compounds are reacting with a nucleophile, remember, it will be undergoing nucleophilic addition reactions. I repeat, nucleophilic addition reactions. So make a print of this statement in your brain. Is that clear? Okay. So one concept we have come to know that whenever a carbonyl group is reacting with a nucleophile, it will be giving you an addition product. Yes. But when I'm talking about its general mechanism, what I'm doing? When I'm talking with respect to a general mechanism, alva ಒಂದು progress of the reaction ನಮಗೆ ಬೇಕು. ಯಾಕೆ ಅಂತ ಈಗ ಹೇಳ್ತೀನಿ ನೋಡಿ. For example, let me take generally a ketone because it will be easy for my representation. I know I will write my ketone will be in this way. Of course, what do I know? This carbon is an sp2 hybridized carbon. Alva carbonyl group in a carbon ಏನಾಗಿರುತ್ತೆ? It is sp2 hybridized. Since it's having a double bond, you can just analyze in that way. But what is the main thing we have to remember about sp2? The structure will be a planar structure. ಏನು ಸರ್ planar ಅಂದ್ರೆ? If I consider this one as a plane, this sheet as a plane, overall this structure will lie on this plane itself. ನಾ ಯಾವ ತರ ಒಂದು ಪೆನ್ ಅಲ್ಲಿ ಬರ್ದಿದ್ದೀನಲ್ಲ, ಇದೇ ರೀತಿ ಇದು ಮೇಲೆ ಶೀಟ್ ಮೇಲೆ ಅದು ಮಲ್ಕೊಂಡಿರುತ್ತೆ. Okay, it is not above the sheet, nor it is lower the sheet. Instead, it is lying on this sheet itself, like how I written the same way. But what happens? Of course, it will not remain as such. Due to the electronegativity difference, what happens? Oxygen will try to attract the pi electrons towards itself. So, of course, now carbon will be having a slight positive charge. So, now what happens? Whatever the nucleophile is there, it is going to attack our carbon. Yes or no? Yes, see the sign is from negative to positive. The arrow marks should always come from negative to positive. Here you have to remember, whenever a nucleophile is attacking the carbon, okay, carbonyl carbon, the sp2 changes to sp3. I repeat, the sp2 changes to sp3. You can just see over here. This is C. Yes, this carbon C. Whereas this is R. This is R. Whatever you are, here you'll be having your O minus, and this will be our nucleophile. So this structure was under the sp2 hybridization having a planar structure. ಆದ್ರೆ ಇಲ್ಲೇನಾಯ್ತು, ಡಬಲ್ ಬಾಂಡ್ ಏನಿತ್ತು ಅದು ಎಲ್ಲ ಕಡೆಗೆ ಸಿಂಗಲ್ ಬಾಂಡೇ ಬಂತು. ನಮ್ಗೆ ಗೊತ್ತಲ್ವ, ಈಗ ನಾನು CH4 ಬರಿಬೇಕು ಅಂದ್ರೆ ಏನಿತ್ತು ಹೈಬ್ರಿಡೈಸೇಷನ್? sp3. ಯಾಕೆ? ಯಾಕಂದ್ರೆ ಬರ್ತಾ ಇರೋದು 4 ಆಟಮ್ಸ್. ಈಗ ನಾವು ಮನೆಯನ್ನ ನಾವು ಉತ್ಪತ್ತಿ ಮಾಡ್ಬೇಕಲ್ವಾ. ಸೊ ಇಲ್ಲಿಗೆ ಎಷ್ಟು ಆರ್ಬಿಟಲ್ಸ್? 3p 1s. ಸೊ ದೇರ್ ಆರ್ 4 hybrid orbitals for 4 hydrogen atoms. But ಇಲ್ಲೇನಾಗಿತ್ತು, ಬರೀ 3 ಇರೋದು. ಸೊ ನಮಗೆ 3 ಸಾಕಿತ್ತು. ಸೊ therefore 2 + 1 3. But here what has happened, since a nucleophile, a guest is arriving, we should vacate a room for him. So therefore what happens, the sp2 gets converted to sp3. So as soon as it gets converted, what happens from the planar, it gives you the tetrahedral structure. It gives you what? Tetrahedral structure. So this part, whatever you are going to get, it is an intermediate. It's an intermediate which is called as what? Alk oxide ion. It is called as alk oxide ion. Are you getting my point? So of course now, before incoming of nucleophile, you are having your aldehydes and ketones sp2 hybridized with a planar structure. As soon as now the your nucleophile is approaching, what happens? It will get converted to sp3, leading to a tetrahedral structure, and whatever the part we have got, it will be an intermediate. Of course, this will not retain. Afterwards, a reaction process which I am going to say, but first you understand the intermediate state. So it will be an intermediate which is called as what? Alko oxide ion. Alkyl and oxide ion it is. Remember. So what happens? This will not retain. Since it's an intermediate, it will pick a proton. It will pick a proton. Let me write it downwards. Since it is in equilibrium, okay, it will pick a proton, and the final product you will be getting in this way. CROH, and here you will be having our nucleophile. So this is your plane. ನೋಡಿರಬಹುದು, ಪ್ಲೇನ್ ಇಂದ ಮೇಲ್ಭಾಗದಲ್ಲಿ NU ಇರುತ್ತೆ. So whatever the nucleophile is coming, it is attacking your carbonyl carbon from the above the plane. Okay, so it has been converted to tetrahedral. ಇದೀಗ ಪ್ಲೇನ್ ಮೇಲಿಲ್ಲ, ಇದೇ ಶೀಟ್ ಅಂತ ತಗೊಂಡ್ರೆ ಈ ಪೆನ್ ನಾನು ನೋಡಿದ್ರೆ ಈ ಪೆನ್ನೇ ನಿಮ್ಮ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್. ಅರ್ಥ ಆಗ್ತಾ ಉಂಟಾ? ಇದು ನಾನು ಕಾರ್ಬನ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಈ ಪ್ಲೇನ್ ಅಲ್ಲೇ ಈಗ ಏನಾಗಿರುತ್ತೆ, R ಇರುತ್ತೆ, OH ಇರುತ್ತೆ, ಆದ್ರೆ ನಿಮ್ಮ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಹೀಗಿರುತ್ತೆ. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಏನಾಗಿದೆ, sp2 ಇಂದ sp3 ಗೆ ಅದು ಬಂದಿದೆ. Are you able to understand? So this is the mechanism you have to remember. So whenever a carbonyl group or a carbonyl compound, that is your aldehydes or ketones, is undergoing nucleophilic addition reaction, you just remember the final product will be having an sp3 hybridized carbon with a tetrahedral structure, and the final product in many of the cases will be in this way itself. Since I have taken a ketone over here, so you'll be having two alkyl groups, one OH group and a nucleophile, which I'm going to say what are those nucleophiles when we are going through the reactions. But this is the general way how does your nucleophilic addition reactions of carbonyl compounds proceeds. Clear with that? If you understand this one, easily we can go with the reactions. Okay, there is no need of by hearting the reaction. First, just you have to understand this state. ಏನ್ ಹೇಳ್ತಾರೆ, ಯಾವತ್ತೇ ನೀವು ಕಾರ್ಬೋನಿಲ್ ಗ್ರೂಪ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಬರೀ ವಿತೌಟ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಇಟ್ ವಿಲ್ ಬಿ sp2. ಯಾಕೆ? ಸಿನ್ಸ್ ಇಟ್ ಇಸ್ ಅ ಡಬಲ್ ಬಾಂಡ್ ಉಂಟು, ಅದನ್ನ ಆಪ್ ಇಟ್ಕೋಬಹುದಲ್ಲ, ಇಟ್ ವಿಲ್ ಬಿ sp2 ವಿಚ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಅ ಪ್ಲೇನಾರ್. sp2 ಅಂತ ಹೇಳ್ಕೊಂಡು ನಿಮ್ಗೆ ಗೊತ್ತಾಗ್ಬಿಡ್ಬೇಕು ಅದು ಪ್ಲೇನಾರ್ ಸ್ಟ್ರಕ್ಚರ್ ಅಂತ. ಅದ್ರ ರಿಯಾಕ್ಷನ್ ಮೂಲಕ ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ, ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ನ ಕೊಡ್ತೀನಿ. ಯಾಕೆ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಆಗ್ತಾ ಉಂಟು? ಬಿಕಾಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರೋನೆಗೆಟಿವ್ ಡಿಫರೆನ್ಸ್ ಬಿಟ್ವೀನ್ ಕಾರ್ಬನ್ ಅಂಡ್ ಆಕ್ಸಿಜನ್. ಕಾರ್ಬನ್ ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಸಮ್ ವಾಟ್ ಡೆಲ್ಟಾ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್. ಸೊ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಆದ್ಕೂಡ ಏನಾಗುತ್ತೆ, ಅದು ಪ್ಲೇನಾರ್ ಅಲ್ಲಿ ಇರಕ್ಕೆ ಇಷ್ಟಪಡಲ್ಲ. ಏನಾಗುತ್ತೆ, ಅದೀಗ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಬಂದು sp3 ಹೈಬ್ರಿಡೈಸೇಷನ್ ಆಗಕ್ಕೆ ಆ ಕಾರ್ಬನ್ ಮೇಲೆ ಕೂರುತ್ತೆ. ಸೊ ಇದೇ ಕಾರ್ಬನ್ sp2 ಏನಿತ್ತು, ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಆದ್ಕೂಡ ಏನಾಯ್ತು, sp3 ಆಯ್ತು. ಯಾಕೆ? ಇನ್ಕಮಿಂಗ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅದೀಗ ಮನೆ ಮಾಡ್ಕೊಡ್ಬೇಕು. ಓಕೆ, ಆ ಗೆಸ್ಟ್ ಹೌಸ್, ಆ ಗೆಸ್ಟ್ ರೂಮ್ ನ ಅದು ವೇಕೆಂಟ್ ಮಾಡ್ಕೊಡ್ಬೇಕು. ಸೊ ಆ ಗೆಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾ ಉಂಟು, ಬಂದ್ಕೊಂಡು ನಂಗೆ ನಿಮ್ಮ ಜೊತೆ ಇರಕ್ಕೆ ಇಷ್ಟ ಇಲ್ಲ, ನಂಗೆ ಮೇಲ್ ಮಾಡಿಲ್ ಮನೆ ಕೊಡಿ ಅಂತ ಹೇಳ್ಕೊಂಡು ಮೇಲ್ ಮಾಡಿಲ್ ಹೋಗಿ ಕೊಡ್ತಾ ಉಂಟು. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, ಎಲ್ಲಾ ಫ್ಯಾಮಿಲಿ ಕೆಳಗಿದ್ರೆ ಬಂದಿರೋ ಗೆಸ್ಟ್ ಏನ್ ಮಾಡ್ತಾನೆ, ಮೇಲ್ ಹೋಗಿ ಕೊಡ್ತಾನೆ. ಸೊ ಅವಾಗ ಏನಾಯ್ತು, sp2 ಇಂದ sp3 ಮೇಲ್ಗಡೆ ಗೆಸ್ಟ್ ರೂಮ್ ಹೋಗಿ ಕೂತಾಗ ಏನಾಯ್ತು, ಸಪರೇಟ್ ಆಗಿ ಒಂದು ರೂಮ್ ಕೊಟ್ರು, ಅದು ನಮ್ಮಿಂದ ಹೊರತುಪಡಿಸಿ. ಸೊ ದಟ್ ವಿಲ್ ಬಿ ಪ್ಲೇನಾರ್ ಇಲ್ಲ, ನಮ್ ಜೊತೆ ಅವರಿಲ್ಲ, ನಮ್ಗಿಂತ ಒಂದು ಸ್ವಲ್ಪ ಮೇಲಿನ ರೂಮ್ ಅಲ್ಲಿ ಇದ್ದಾರೆ. ಸೊ ದಟ್ ಈಸ್ ಇಂಡಿಕೇಟಿಂಗ್ ಓವರ್ ಹಿಯರ್. ಓಕೆ, where sp2 has been converted to sp3, okay, which will be having a tetrahedral structure, and whenever such a nucleophile is attacking, first you will be getting an intermediate. ಅಲ್ವಾ, ಡೈರೆಕ್ಟ್ ಆಗಿ ನಮಗೆ ಪ್ರಾಡಕ್ಟ್ ಬರಲ್ಲ. ಪ್ರಾಡಕ್ಟ್ ಬರಕ್ಕಿಂತ ಮೊದಲು ಏನ್ ಮಾಡ್ತೀವಿ, ಫಸ್ಟ್ ನಮ್ಗೆ ಒಂದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಬರುತ್ತೆ ಅಲ್ವಾ. ನಾವು ಓದಿದ್ವಿ ಕೆಟಾಲಿಸ್ಟ್ ಪಾರ್ಟ್ ಅಲ್ಲಿ, ಅದನ್ನು ಒಂದ್ಸರಿ ನೀವು ತಿರ್ಗಿ ಹಾಕಿ. ಯಾವತ್ತೇ ಒಂದು ರಿಯಾಕ್ಟೆಂಟ್ ಪ್ರಾಡಕ್ಟ್ ಕೊಡಬೇಕು ಅಂದ್ರೆ ಫಸ್ಟ್ ಇಟ್ ಹ್ಯಾಸ್ ಟು ಗೋ ವಿತ್ ಸೆವರಲ್ ಸ್ಟೆಪ್ಸ್. ಸ್ಟೆಪ್ ಬೈ ಸ್ಟೆಪ್ ಇಟ್ ಇಸ್ ಗಿವಿಂಗ್ ಯು ದಿ ಲಾಸ್ಟ್ ಪ್ರಾಡಕ್ಟ್. ಆ ಸ್ಟೆಪ್ ಮಧ್ಯದಲ್ಲಿ ಏನಿರುತ್ತಲ್ಲ ಅವೆಲ್ಲ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಸ್ಟೇಜಸ್. ಇಟ್ ವಿಲ್ ನಾಟ್ ಲಾಂಗ್ ಫಾರ್ ಅ ಲಾಂಗರ್ ಟೈಮ್. ಅದು ಬ್ರೇಕ್ ಆಗಿ ನಮಗೆ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಸಿಗುತ್ತೆ. ಇಲ್ಲೇನಾಗ್ತಾ ಉಂಟು, ಫಸ್ಟ್ ಒಂದು ಇಂಟರ್ಮೀಡಿಯೇಟ್ ಕೊಡುತ್ತೆ. ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಬಂದ್ ಕೂತ್ ಕೂಡ ಏನಾಯ್ತು, ಇಲ್ಲಿ O- ಇತ್ಕೊಂಡಿತ್ತಲ್ಲ, ಅದಕ್ಕೆ ತಾನೇ C+ ಆಯ್ತು, ಅವಾಗ ಅಲ್ಲಿ ಬಂದು ಕೂರ್ತು. ಸೊ ಅಲ್ಲಿಗೆ ಏನಾಯ್ತು, O- ಹಾಗೇನುಂಟು, ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಬಂದು ಕೂತಿದೆ. ಸೊ ದಟ್ ಇಸ್ ಅನ್ ಇಂಟರ್ಮೀಡಿಯೇಟ್ ವಿಚ್ ಇಸ್ ಕಾಲ್ಡ್ ಅಸ್ ವಾಟ್, ಆಲ್ಕೋ ಆಕ್ಸೈಡ್. ಸೊ ದಿಸ್ ಆಲ್ಕೋ ಆಕ್ಸೈಡ್ ಏನ್ ಮಾಡುತ್ತೆ, ಒಂದು ಪ್ರೋಟಾನ್ ಪಿಕ್ ಮಾಡುತ್ತೆ. ಅದು ನಾವು ರಿಯಾಕ್ಷನ್ ನೋಡ್ತೀವಿ ಯಾವ ತರ ಪ್ರೋಟಾನ್ ಪಿಕ್ ಮಾಡಿ. ಸಮಟೈಮ್ಸ್ ಇಟ್ ಕ್ಯಾನ್ ಪಿಕ್ ದಿ ಪ್ರೋಟಾನ್ ಫ್ರಮ್ ದಿ ಮಾಲಿಕ್ಯೂಲ್ ಇಟ್ ಸೆಲ್ಫ್, or sometimes from the solvent. We will see through it. Okay, so, but when it is picking up a proton, the final stage, this will be the ultimate stage of the products of your nucleophilic addition reactions of carbonyl compounds. Is that clear? I hope there is no doubt. Okay, so before going to the main concepts of the reaction, let me ask you a question. Of course, if you have understood, you can easily answer these questions. So first question, let me ask you. Since again and again I said that carbonyl compounds undergoes nucleophilic addition reactions. Yes. And I have said you carbonyl compounds you are having both aldehydes and ketones. Now my first question to you, remember, please pay attention. Whether your aldehydes are more reactive. I'm asking you a question, okay? This is my question. I'm not giving you a statement. I'm asking you whether aldehydes are more reactive. Whether aldehydes are more reactive towards, I will write it as nucleophilic addition reaction. This is not a representation, just for time management. I have written, you don't write this, just I'm saying you. Whether aldehydes are more reactive towards nucleophilic addition reaction or ketones are more reactive towards nucleophilic addition reaction. This is my question. I repeat my question once again. I'm asking you, you are having now aldehydes and ketone. Okay, you just think in a while. And you have to do a nucleophilic addition reaction. Which one? Whether aldehyde will give you first product or whether ketone will give you first product. ಯಾವುದು ಬೇಗನೆ ನಿಮಗೆ ಪ್ರಾಡಕ್ಟ್ ಕೊಡುತ್ತೆ ಅನ್ನೋದನ್ನ ಕ್ವಶನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. Since you have seen the mechanism, you have seen how the nucleophile is attacking, the answer lies within that, whatever we have just learnt now. I'm giving you 5 seconds. Yes. So if your answer is aldehydes are more reactive towards nucleophilic addition reaction, well and good, you have understood the concept. Those who have not able to answer, let us go on with it. When I am writing, for example, an aldehyde, how can I write? R, C, double bond O and a H over here. Alva. When I write a ketone, let me write downwards. Okay, let me write a ketone over here. R, C, double bond O and a R. Of course, a nucleophile has to attack, means what should happen? Yes, this oxygen should attract the pi electrons towards itself. So in that case, what happens? Of course, your delta minus on oxygen, delta plus on carbon. Here also what happens? Delta minus on oxygen, delta plus on carbon. Of course, what I said, carbonyl compounds will undergo addition. Aage agutte, adu yavadu bega agutte annadu nama question iga. So ಈಗ ಏನು ಮಾಡ್ತೀನಿ ನಾನು nucleophile ನ ಬಿಡ್ತೀನಿ. Okay, same nucleophile. In both the cases, I am going to attack the nucleophile. Attacking is same. Both are same nucleophiles. You just observe over here. This is also electron rich. Alva. This is also electron rich. Okay. When I talk about ketones, this is also electron rich. This is also electron rich. On top of that, here one more alkyl group is present. Which means what? There are 2 electron donating groups. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು? ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಉಂಟು ಯಾವ್ದ್ರಲ್ಲಿ? ಕೀಟೋನ್ಸ್ ಅಲ್ಲಿ. ಬರ್ತಾ ಇರಕ್ಕೂ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಉಂಟು. ಕೀಟೋನ್ ಅಲ್ಲಿ ಕೂಡ 2 ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಇರೋ ಗ್ರೂಪ್ಸ್ ಉಂಟು. ಅವಾಗ ಏನಾಗುತ್ತೆ? ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಬೇಗ ಬಂದ್ ಕೂರಕ್ ಆಗ್ತಾ ಇಲ್ಲ ಅಲ್ವಾ? ಆದ್ರೆ ಆಲ್ಡಿಹೈಡ್ಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ? ಒಂದೇ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಇರೋ ಕಾರಣದಿಂದ ರಿಪಲ್ಷನ್ ಇದ್ದೇ ಇರುತ್ತೆ. ಆದ್ರೆ ಏನು ಕೀಟೋನ್ಸ್ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ that repulsion is very small. Able to understand? So therefore nucleophile can easily come and sit on aldehydes. ಇಲ್ಲಿ ಒಂದ್ ಸ್ವಲ್ಪ ಡಿಲೇ ಆಗುತ್ತೆ. ಯಾಕೆ? ರಿಪಲ್ಷನ್ ನ ತಡ್ದಿ ಅದು ಬಂದು ಹೆಂಗೋ ಮಾಡಿ ಕೂರ್ಬೇಕು. ಸೊ ಅದೇನ್ ತಡೆದು ಬರ್ತಾ ಉಂಟು, ಅದು ಟೈಮ್ ತಗೊಂತಾ ಉಂಟು. ಆದ್ರೆ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಹಂಗ ಇಲ್ಲಿ ಆಲ್ಡಿಹೈಡ್ಸ್ ಹಂಗ ಆಗಲ್ಲ. ಯಾವ್ದೋ ಒಂದ್ ಕಡೆ ಅದು ಪೊಸಿಷನ್ ಸಿಗುತ್ತೆ. ಯಾಕೆ? ಬರೀ ಒಂದೇ ಕಡೆ ಮಾತ್ರ ನಿಮ್ಮ ಆಲ್ಕಿಲ್ ಗ್ರೂಪ್ ಇರೋದು. ಆದ್ರೆ ಇಲ್ಲೇನಾಗಿದೆ 2 ಕಡೆನೂ ಉಂಟು. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಏನಾಗುತ್ತೆ, ಈ ನ್ಯೂಕ್ಲಿಯೋಫೈಲು ಆಲ್ಡಿಹೈಡ್ ಗೆ ಅಪ್ರೋಚ್ ಮಾಡೋದು ಸುಲಭ ಆಗುತ್ತೆ. So once it is easy for the nucleophile to come and sit, what happens? Easily the reaction proceeds to give us the nucleophilic addition product. So that is the reason, remember, aldehydes are always more reactive than ketones towards the nucleophilic addition reactions. Make a note of it. I repeat once again, aldehydes are more reactive than ketones towards nucleophilic addition reactions. Very important note you have to remember. Is that clear? Carbonyl groups nucleophilic addition reaction ಆಗೆ ಆಗುತ್ತೆ. ಆದ್ರೆ ಆ ಕಾರ್ಬೋನಿಲ್ ಕಂಪೌಂಡ್ಸ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ಆಲ್ಡಿಹೈಡ್ಸ್ ಮತ್ತೆ ಕೀಟೋನ್ಸ್ ಬರುತ್ತೆ. ಆ ಆಲ್ಡಿಹೈಡ್ಸ್ ಆರ್ ಮೋರ್ ರಿಯಾಕ್ಟಿವ್ ವೆನ್ ಯು ಕಂಪೇರ್ ಟು ದಟ್ ಆಫ್ ಯೋರ್ ಕೀಟೋನ್ಸ್. ದ ಓನ್ಲಿ ರೀಸನ್ ಇಸ್ ಬಿಕಾಸ್ ಆಫ್ ದಿ ಲೆಸ್ ಸ್ಟಿರಿಕ್ ಹಿಂಡ್ರೆನ್ಸ್ ಇನ್ ಅವರ್ ಆಲ್ಡಿಹೈಡ್ಸ್. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಕೀಟೋನ್ಸ್ ಅಲ್ಲಿ ಜಾಸ್ತಿ ಸ್ಟಿರಿಕ್ ಹಿಂಡ್ರೆನ್ಸ್ ಉಂಟು, ಆದ್ರೆ ಆಲ್ಡಿಹೈಡ್ಸ್ ಅಲ್ಲಿ ಕಮ್ಮಿ ಸ್ಟಿರಿಕ್ ಹಿಂಡ್ರೆನ್ಸ್ ಉಂಟು. ಇಸ್ ದಟ್ ಕ್ಲಿಯರ್? ಓಕೆ, ನೋ ಪ್ರಾಬ್ಲಮ್. ಕ್ಯಾನ್ ವಿ ಪ್ರೊಸೀಡ್? ಓಕೆ, ವೆಲ್ ಅಂಡ್ ಗುಡ್. ನಾವ್ ಸರ್ ಆಲ್ಡಿಹೈಡ್ಸ್ ಅಂತ ಹೇಳಿದ್ರಿ, ಪ್ರಾಬ್ಲಮ್ ಇಲ್ಲ ಸರ್. ಆದ್ರೆ ಈಗ ನಂಗೊಂದು ಡೌಟ್ ಉಂಟು. ಏನದು ಡೌಟು? ಈಗ ನನ್ನ ಹತ್ರ ಪ್ರೋಪೆನಾಲ್ ಉಂಟು. ದಿಸ್ ಇಸ್ ಮೈ ಸೆಕೆಂಡ್ ಕ್ವಶನ್ ಟು ಯು. ಆಮೇಲೆ ಬೆನ್ಸ್ ಆಲ್ಡಿಹೈಡ್ ಉಂಟು. ಒಂದು ನಂದು ಅಲಿಫ್ಯಾಟಿಕ್ ಆದ್ರೆ ಇನ್ನೊಂದು ಆರೈಲ್ ಸಿಸ್ಟಮ್ ಉಂಟು. ಆದ್ರೆ 2 ಆಲ್ಡಿಹೈಡ್ ಗ್ರೂಪಿಗೆ ಬಿಲಾಂಗ್ ಆಗುತ್ತೆ ಅಲ್ವಾ? ಇದು ಹೆಂಗ್ ಬರಿಬಹುದು ನಾನು? CH3 CH2 CHO. Whereas benzaldehyde ಅಂದ್ರೆ ಬೆನ್ಝೀನ್ ರಿಂಗಿಂಗ್ ಆಲ್ಡಿಹೈಡ್ ಗ್ರೂಪ್ ಇರುತ್ತೆ. ಲೆಟ್ ಮಿ ರೈಟ್ ಓವರ್ ಹಿಯರ್. ಸಿ ಈಸಿಯಾಗಿ ಬರೀಬೇಕಂದ್ರೆ ಡಬಲ್ ಬಾಂಡ್ O ಅಂಡ್ H ಈ ತರ ಉಂಟು. Now the question is whether propanol will undergo the nucleophilic addition reaction at a faster rate or whether benzaldehyde will undergo the nucleophilic addition reaction at a faster rate. ಅರ್ಥ ಆಯ್ತಾ ಕ್ವಶನ್? ಪ್ರೋಪೆನಾಲ್ ನಿಮ್ಗೆ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಬೇಗ ಆಗುತ್ತೋ ಅಥವಾ ಬೆನ್ಸಾಲ್ಡಿಹೈಡ್ಗೆ ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಬೇಗ ಆಗುತ್ತೋ ಅನ್ನೋ ಕ್ವಶನ್. ಸೊ ರಿಮೆಂಬರ್, ನ್ಯೂಕ್ಲಿಯೋಫೈಲಿಕ್ ಅಡಿಷನ್ ಆಗ್ಬೇಕು ಅಂದ್ರೆ ಒಂದೇ ಕಾನ್ಸೆಪ್ಟ್, ಏನದು? ಫಸ್ಟ್ ಕಾರ್ಬನ್ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರೋ ಸಾಧ್ಯತೆಗಳುಂಟಾ ಅಂತ ನೋಡ್ಕೋಬೇಕು. ಅಫ್ಕೋರ್ಸ್ ಇಲ್ಲೇನಾಗುತ್ತೆ, ಇದು ನಾನು ಬರ್ದೆ ಸಿ ಡಬಲ್ ಬಾಂಡ್, ಇಲ್ಲಿ ಹೆಚ್ಚಿ ತರ ಬರೀಬಹುದಲ್ವಾ. ಅಫ್ಕೋರ್ಸ್ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಓ ತಗೊಳುತ್ತೆ, ಈಸಿಯಾಗಿ ಡೆಲ್ಟಾ ಪ್ಲಸ್ ಬಂತು ಪ್ರೊಪೆನಾಲ್ ಅಲ್ಲಿ. ಆದ್ರೆ ಬೆನ್ಸಾಲ್ಡಿಹೈಡ್ ಅಲ್ಲಿ ರಿಮೆಂಬರ್ ಇಟ್ ಇಸ್ ನಾಟ್ ಸೋ ಈಸಿ. ವೈ? ಬಿಕಾಸ್ ದಿಸ್ ಫಿನೈಲ್ ರಿಂಗ್, ವಾಟ್ ಇಟ್ ವಿಲ್ ಟ್ರೈ ಟು ಡೂ, ಇನ್ಸ್ಟೆಡ್ this pi electron to be taken by oxygen, the benzene ring is having the higher potential to take the pi electrons towards itself. So ಇದೇನ್ ಮಾಡುತ್ತೆ, ಆಕ್ಸಿಜನ್ ಹೋಗೋ ಬದಲು ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಂಡು ತನ್ನ ಕಡೆಗೆ ಎಳ್ಕೊಂಡಾಗ ಇದನ್ನ ಯಾವ ತರ ಬರೀಬಹುದು? ಈಗ ಇಲ್ಲಿಗೆ ಬಂತು, ಅವಾಗ ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ರೆಸೋನೆನ್ಸ್ ಬರ್ತಾ ಹೋಗುತ್ತೆ. ನಾ ರೆಸೋನೆನ್ಸ್ ಬರೆಯಲ್ಲ, ಬರೀ ಒನ್ ಸ್ಟ್ರಕ್ಚರ್ ಬರೀತೀನಿ. ಸೊ ಹಿಯರ್ ನಾವು ವಿಲ್ ಬಿ ಹ್ಯಾವಿಂಗ್ ಡಬಲ್ ಬಾಂಡ್ ಸಿ, ಸಿಂಗಲ್ ಬಾಂಡ್ ಓ ಅಂಡ್ ಹೆಚ್. ಅಫ್ಕೋರ್ಸ್ ಇಲ್ಲಿಗ ಓ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರ್ತಾ ಉಂಟು. ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನಾವು ಯು ಕ್ಯಾನ್ ಓನ್ಲಿ ಸಿ, ಇಲ್ಲಿಗ ನೆಗೆಟಿವ್ ಬಂತು. ಸೊ ದೇರ್ ಇಸ್ ಅ ಡಬಲ್ ಬಾಂಡ್ ಕ್ಯಾರೆಕ್ಟರ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ದಿ ಸಿ. ಸಿ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರಲ್ಲ. ಸೊ ಆ ರೀಸನ್ ಇಂದನೇ ಸಿ ಮೇಲೆ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಬರಲಿಲ್ಲ ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ಆಗೋದು ಕಷ್ಟ ಉಂಟು. ಸೊ ದಟ್ ಈಸ್ ಅ ರೀಸನ್ ಪ್ರೋಪೆನಾಲ್ ವಿಲ್ ಬಿ highly reactive. Propanol will be highly reactive towards nucleophilic addition reactions than that of your benzaldehydes, Getting my point why I am saying this? So whatever the pi electrons which were in between the carbon and oxygen, that has been taken by the benzene ring itself, forming a double bond character between benzene and that of your carbonyl carbon. So that carbon will not be having now positive charge. So therefore the nucleophile can't come and attack your carbon. So therefore ಏನಾಗುತ್ತೆ, nucleophilic addition reaction reactivity decrease ಆಗುತ್ತೆ. ಆದ್ರೆ ಆತರ ಒಂದು ನಾವು ಪ್ರೊಪೆನಾಲ್ ಅಲ್ಲಿ ನೋಡ್ತಾ ಇಲ್ಲ. ನೀವೇ ನೋಡಬಹುದಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆಗಿ ಅದೇ ಹೇಳ್ಕೊಂತ, ಯಾಕಂದ್ರೆ ಇವಕ್ಕೆ ಹೇಳ್ಕೊಳೋ ಶಕ್ತಿ ಇಲ್ಲ. ಇಲ್ಲಾದ್ರೆ ಏನಾಯ್ತು, ಕಂಪೇರ್ ಟು ಆಕ್ಸಿಜನ್ ಬೆನ್ಸಿನ್ ರಿಂಗಿಗೆ ಹೇಳ್ಕೊಳೋ ಶಕ್ತಿ ಜಾಸ್ತಿ ಇತ್ತು. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಏನಾಯ್ತು, ಆಕ್ಸಿಜನ್ ಕೊಡ್ಲಿಲ್ಲ ಅದು ಆ ಟೈಮ್ ಅದು ಏನ್ ಮಾಡ್ಕೊಂಡು ತಾನೇ ಯೂಸ್ ಮಾಡ್ಕೊಂಡು ಆ ಕಾರ್ಬೋನಿಲ್ ನಿಂದ ಡಬಲ್ ಬಾಂಡ್ ತನ್ನ ಕಡೆ ಹೇಳ್ಕೊಬಿಡುತ್ತೆ. ಅವಾಗ ಏನಾಯ್ತು, ಕಾರ್ಬನ್ ಮತ್ತೆ ಬೆನ್ಸಿನ್ ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಡಬಲ್ ಬಾಂಡ್ ಕ್ಯಾರೆಕ್ಟರ್ ಬಂತು. ಸೊ ಆ ರೀಸನ್ ಇಂದ ಈ ಕಾರ್ಬನ್ ಮೇಲೆ ಯಾವ ತರ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗಲ್ಲ. ಸೊ ಅವಾಗ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಕೂಡ ಅಟ್ಯಾಕ್ ಆಗಕ್ಕಾಗಲ್ಲ. ಸೊ ವೆನ್ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಇಸ್ ನಾಟ್ ಅಟ್ಯಾಕಿಂಗ್, ವಾಟ್ ಹ್ಯಾಪನ್ಸ್, ನ್ಯೂಕ್ಲಿಯೋಫಿಲಿಕ್ ಅಡಿಷನ್ ರಿಯಾಕ್ಷನ್ ಆಗೋದು ಸ್ವಲ್ಪ ಕಷ್ಟ ಆಗುತ್ತೆ. Is that clear? So that is the reason your propanol will be highly reactive than that of your benzaldehyde towards the nucleophilic addition reaction. So make a note of this too. Okay? So first ಏನು ಗೊತ್ತಾಯ್ತು, aldehydes ಮತ್ತೆ ketones ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ aldehydes are more reactive towards the nucleophilic addition reaction. But when we considering your propanol and benzaldehyde and the aliphatic system and aryl system ನ ಕನ್ಸಿಡರ್ ಮಾಡಿದಾಗ ನಿಮ್ಮ aliphatic system ಗೆ ಜಾಸ್ತಿ ಟೆಂಡೆನ್ಸಿ ಇರುತ್ತೆ, ಅದು ಜಾಸ್ತಿ ರಿಯಾಕ್ಟಿವಿಟಿ ಇರುತ್ತೆ ಟುವರ್ಡ್ಸ್ ಅವರ್ nucleophilic addition reaction. Aliphatic system of aldehydes, please remember, aliphatic system of aldehydes will be more reactive towards your nucleophilic addition reactions. Is that clear? So there is no doubt. Can we have a quick revision whatever we have done today? Okay, so today we have been dealt with the chemical properties of the carbonyl compounds, where we have come to know that when you are checking out the structures of your carbonyl group, your carbon atom is having a partial positive charge. So therefore the incoming nucleophile is going to attack that carbon, and whatever the final product you are going to get, it will be an addition product of your nucleophilic. So therefore the reaction is called as what? Nucleophilic addition reactions. So there we have seen the mechanism. So whenever we talk about just the carbonyl group, they will be sp2 hybridized and having a planar structure. As soon as the nucleophile is attacking the carbonyl carbon, the sp2 gets changes to sp3 hybridized. Yes or no? So once it gets sp3 hybridized, what happens to its structure? From the planar, it has to form a tetrahedral structure where it will be an intermediate called as an alkoxide ion. So this alkoxide ion will be in equilibrium to that of your final product, where your alkoxide ion is going to pick up a proton and giving you the final nucleophilic addition product. Is that clear? Very much important, because whatever the final product we are going to get, it will be in this stage itself. Just ನಿಮ್ಗೆ R ಮತ್ತೆ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಮಾತ್ರ ಚೇಂಜ್ ಆಗ್ತಾ ಬರುತ್ತೆ ವಿನಃ OH ಹಂಗೆ ಇರುತ್ತೆ. So that is the reason this is a general representation of what type of a product you're going to get in your nucleophilic addition reaction. Then coming with respect to some important notes, your aldehydes will be more reactive towards the nucleophilic addition reaction because of the less steric hindrance, which I have explained over here. Then coming with respect to the second note, within the aldehydes, your aliphatic aldehydes will be more reactive towards your nucleophilic addition reaction than that of your benzaldehyde. The only reason is because whatever the pi electrons which is existing in a carbonyl group, it will be withdrawn by the benzene ring, forming a benzene and the carbonyl carbon with a double bond. Is that clear? So that is the reason the reactivity of the benzaldehyde towards the nucleophilic addition reaction decreases. Is that clear? So next, once we have understood all this concept, we are going to deal with some important nucleophilic addition reactions itself. I repeat, nucleophilic addition reaction. In this video, I am just going to cover two nucleophilic addition reactions. In the later videos, we'll be having other nucleophilic addition reaction. In order to not to confuse you, in this video, only two. That is, first one we are going to see with hydrogen cyanide. That is what happens when carbonyl groups are treated with a hydrogen cyanide. And the second one with sodium bisulfite. How will you write? Sodium bisulfite I am saying. So bi andre NaH, sulfite SO3. So NaHSO thrice. Okay. So ಇದು ಯಾವ ತರ ನಿಮಗೆ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಬರುತ್ತೆ ಅಂತ ನೋಡಿ ನಾವು ಜಡ್ಜ್ ಮಾಡಿ ನಮ್ಮ ಫೈನಲ್ ರಿಯಾಕ್ಷನ್ಸ್ ನ ಬರೆಯೋಣವಾ? Okay. So guys, now let us start with the first important nucleophilic addition reaction, that is, what happens when carbonyl compounds are treated with hydrogen cyanide. Hydrogen cyanide. Very much important, both in the point of your PU board exams and to that of your competitive exams. Okay? ಯಾವ ತರ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ ಅನ್ನೋದನ್ನ ನೋಡ್ಕೊಂಡು ಆ ಪ್ರಾಡಕ್ಟ್ ನ ಹೆಸರು ಏನು ಅನ್ನೋದನ್ನು ತಿಳ್ಕೋಬೇಕು. So remember, whenever carbonyl compounds, whenever the carbonyl compounds are treated with hydrogen cyanide, remember, in the presence of base, very much important. I would be saying why we are using the base soon after we have seen the reaction. I repeat, whenever the carbonyl compounds is treated with a hydrogen cyanide in the presence of base, the product we are going to obtain is called as cyanohydrines. Cyanohydrines. Very much important to note the names of the product. So whenever the carbonyl compounds are treated with a hydrogen cyanide in the presence of a base, we are going to get as a cyanohydrines. Okay. Now you could only judge. What you can judge, of course, ಈಗ ಇಲ್ಲಿ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಯಾವ್ದಾಗಿರುತ್ತೆ ಅನ್ನೋದು ನೀವೇ ಜಡ್ಜ್ ಮಾಡಿ. So yes, H plus CN minus. So when I am writing my carbonyl group, how can I write? I could write it in this way as C double bond O, as we have written earlier in this case. So ಈಗ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಬದಲು ಏನ್ ಬರಬೇಕಿಲ್ಲಿ? CN minus. So what will happen over here? CN minus. So how it is going to attack? Of course, now this oxygen will take the electrons towards itself. So now this carbon will be having a positive charge. Always the arrow mark should be from negative to positive. Yes or no? So again, how can you write? You will be having CO minus. Here you will be having your CN. Very much important. See the part, it has been attacking to that of your carbonyl carbon with the cyanide's carbon, because cyanide is an ambident ligand, if you just recall, alva. So the structure or the bonding is from the cyanide's carbon to that of your carbonyl carbon. But it doesn't stop over here. Of course, we know it has to take. Now this is an intermediate stage, which is an alkoxide ion. So now the final thing you will be getting that of your, so CN and an OH. Is that clear? So this part is called as what? Cyanohydrine. Cyanohydrine. That is the reason I have mentioned initially the mechanism. Enu change agilla, mechanism ರೀತಿಲೇ ಬಂದಿದೆ. ಏನಂದ್ರೆ ನಾವು alkyl groups ಮತ್ತೆ nucleophile ನ ಮಾತ್ರ change ಮಾಡ್ತೀವಿ. Is that clear? Let us go with some examples for you. Okay. So for example, if I am going to take now acetaldehyde. Acetaldehyde means IUPAC name ethanol. So CH3 C double bond OH. So what happens when it is treated with a hydrogen cyanide in the presence of some suitable base. Just write the final product. No need of showing anything. ಯಾಕಂದ್ರೆ ಇದು ಕಂಪ್ಲೀಟ್ ರಿಯಾಕ್ಷನ್ ರೇಟ್ ಅಲ್ಲಿ ಕೊಟ್ಟಾಗ ನೀವು ಇದೇ ರೀತಿ ಬರೀಬೇಕು. ಸೊ ಯಾವ ತರ ಬರೀಬಹುದು ಇದೆ CH3 ಉಂಟು. ಈಗೇನಾಗುತ್ತೆ O ಜಾಗಕ್ಕೆ OH ಬರಿಬೇಕು ಅಲ್ವಾ. O ಮೈನಸ್ ಇದ್ದು H ತಗೊಂಡು OH ಆಯ್ತು. ಅದೇ ಕಾರ್ಬನಿಗೆ ಈಗ ಏನಾಗಿರುತ್ತೆ ನಮ್ಮ ನ್ಯೂಕ್ಲಿಯೋಫೈಲ್ ಅಟ್ಯಾಕ್ ಆಗಿರುತ್ತೆ. ಇನ್ನೊಂದು H ಹಾಗೇನೆ ಇರುತ್ತೆ. This is called as what? Acetaldehyde cyanohydrine. Acetaldehyde cyanohydrine. Are you getting my point? See, nothing we have done. So this is the way of representation. Complete the reaction. You have to just write it this way. Is that clear? Or when they ask you, give a brief note on the addition of HCN or hydrogen cyanide to the carbonyl compounds, then you have to explain what I have explained here, with showing each and everything's proper. But when they are giving you a particular aldehyde or ketone, you just write the final product. Is that clear? There is a possibility you can write, but don't waste the time. Unless and until they have asked, why you waste your time? Directly you write it and write the final structure. Okay? Let us take one more. Let me take a acetone, a ketone I will be taking. CH3, C double bond O and a CH3. This is a general or common name. Common name is acetone, whereas that of your IPAC name is propanone. Alva. So when it is treated with a HCN in the presence of base, how can you write it? Can you please help me out? Yes, sir. CH3. This CH3 is there. C is there. Now what should happen? Double bond has been converted to a single bond. O minus irutte intermediately, it will pick up a proton. Yes, incoming nucleophile will attack your carbonyl carbon. Here comes your CN, and as usual, here comes your CH3. Yes or no? So this is called as what? Acetone cyanohydrine. Acetone cyanohydrine. Getting my point? Very much important. Now if I will ask you a question, whether acetaldehyde will give you acetaldehyde cyanohydrine at a faster rate, or whether acetone will give you acetone cyanohydrine at a faster rate. ಈಗ ನಿಮ್ಮ ಹತ್ರ 2 ಬೀಕರ್ ಉಂಟಪ್ಪ ಆಯ್ತಾ. ಒಂದಲ್ಲಿ ನೀವೇನ್ ಮಾಡಿದ್ದೀರಾ ಅಸಿಟಾಲ್ಡಿಹೈಡ್ ನ ಯೂಸ್ ಮಾಡಿದ್ದೀರಾ, ಇನ್ನೊಂದಲ್ಲಿ ಏನ್ ಮಾಡಿದ್ದೀರಾ ಅಸಿಟೋನ್ ನ ಯೂಸ್ ಮಾಡಿದ್ದೀರಾ. ಇವೆರಡಕ್ಕೂ ನಾನು HCN ಮತ್ತೆ ಬೇಸ್ ಹಾಕ್ತೀನಿ. ಯಾವುದು ನಂಗೆ ಅತಿ ಫಾಸ್ಟ್ ಆಗಿ ಪ್ರಾಡಕ್ಟ್ ಕೊಡುತ್ತೆ? Getting my point? Which one? Either aldehyde or whether ketone will give you the product faster? Of course, our aldehyde. We have seen it, alva. Aldehyde's reactivity towards that of your nucleophilic addition reaction will be quicker. So therefore, first, if you are using simultaneously use martidana, first namge acetaldehyde cyanohydrine marutte. After some time, we'll be getting what? Acetone cyanohydrine. Is that clear? Very much important to note this point. So nothing we have changed. So the addition of HCN to a aldehyde or ketone, it is an example of nucleophilic addition reaction. That is the reason I have mentioned again and again the mechanism. See, nothing we have changed. In both the cases, you can just see there R is changed and that of your nucleophile is changed, whereas in both the cases OH is prevailing. So if you remember this mechanism easily, you can only write or you can only predict the products. Is that clear? Just you have to remember what is the nucleophile you are generating. Is that clear? No problem. Okay. As I have said, now the question arises over here. Why I am using the base over here? Remember guys, your pure HCN iddaga adu decompose agi H plus ಮತ್ತೆ CN minus ಕೊಡೋದು ಸ್ವಲ್ಪ ಟೈಮ್ ಆಗುತ್ತೆ. It is taking some time. So therefore what we do, we add a base over here. So as soon as you add a base, what happens? It will promote the dissociation of HCN, and easily first of all it will react HCN plus that of your OH minus of your base. Easily ಆಗಿ ನಿಮಗೆ ಏನು ಮಾಡುತ್ತೆ CN minus a strong nucleophile ನ ಕೊಟ್ಟಿ ತನಗೆ ತಾನು ವಾಟರ್ ಆಗಿ ಕನ್ವರ್ಟ್ ಆಗಿಬಿಡುತ್ತೆ. In order to promote the dissociation of HCN at a faster rate, your base is added. So that is the reason I am saying whenever we are carrying out the hydrogen cyanide reactions with the carbonyl compounds, base plays a vital role because to promote the reaction at a faster rate. Chemistry one what is that? We want the reaction to occur first. Important point, at a maximum yield. Whatever the product you should get, it should be maximum yield. And the second most important thing, the rate of the reaction will be much faster. ಎಷ್ಟು ಬೇಗ ಆಗುತ್ತೋ ಅಷ್ಟು ಒಳ್ಳೆಯದು. Because whatever we are studying alwa, it is all major applications. Industry ನಾವು ಯೂಸ್ ಮಾಡೇ ಮಾಡ್ತೀವಿ. So industry ಏನು ಮಾಡುತ್ತೆ, it will not wait. They want two important things. What is that? they should get the maximum yield at a faster rate. ಸೊ ಆ ಒಂದು ಮೆಥಡ್ ನಾವು ಎಲ್ಲಿಗೆ ಏನ್ ಮಾಡಿದ್ರೆ ಆ ತರ ಒಂದು ರಿಯಾಕ್ಷನ್ ಬರುತ್ತೆ ಅಂತ ನಾವು ನೋಡ್ತೀವಿ. ಬರೀ HCN ಹಾಕಿದಾಗ ಅಫ್ಕೋರ್ಸ್ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ, ಅದೇ ಏನು ಟೈಮ್ ತಗೊಳುತ್ತೆ ಜಾಸ್ತಿ. ಅದೇ ನೀವು ಬೇಸ್ ಹಾಕಿದಾಗ ಏನಾಗುತ್ತೆ, ಬೇಗನೆ ಪ್ರಾಡಕ್ಟ್ ಬರುತ್ತೆ. ಸೊ ಆ ರೀಸನ್ ಇಂದ ನಮ್ಗೆ ಗೊತ್ತಿರಬೇಕು, ಬೇಸ್ ಹಾಕಿದಾಗ ರಿಯಾಕ್ಷನ್ ಬೇಗ ಆಗುತ್ತೆ. ಇಸ್ ದ್ಯಾಟ್ ಕ್ಲಿಯರ್? ವೆರಿ ಮಚ್ ಇಂಪಾರ್ಟೆಂಟ್ ಪಾಯಿಂಟ್. ಇಸ್ ದ್ಯಾಟ್ ನೋ ಪ್ರಾಬ್ಲಮ್? ಸೊ ಫಸ್ಟ್ ಇಂಪಾರ್ಟೆಂಟ್ ರಿಯಾಕ್ಷನ್ಸ್ ವಿ ಹ್ಯಾವ್ ಸ್ಟಡಿಡ್, ದಟ್ ಈಸ್ ವಿತ್ hydrogen cyanide. So guys, now let us go with the second most important nucleophilic addition reaction, which is called as treatment of your carbonyl compounds with, okay, let me write its name itself, with sodium bisulfite. Sodium bisulfite. So just you see the reaction, first I'm going to write. Okay, remember most of the aldehydes and few ketones, mark my words, most of the aldehydes and few ketones react with the saturated solution of your sodium bisulfite to form white crystalline precipitate of a bisulfites. You'll come to know when I write the reaction what I have mentioned. Let me take over here as a ketone itself, RCR, or let me don't write it, confusion banala, double bond, oh ite rete barbidan, RD carbonyl group na ತಗೊಂಡಿದ್ದೀವಿ. Of course ಏನು ಮಾಡುತ್ತೆ, ಈಗ ಇದು ಈ ಕಡೆ ಬರುತ್ತೆ O minus, ಈಗ ಇಲ್ಲಿ ಯಾವುದು ಬರುತ್ತೆ, if I write as a NaHSO3, of course it is going to give as Na plus plus HSO3 minus. Remember this negative side is on the sulfur atom. Why I am saying this, you know, because when you are forming a bond with your carbonyl carbon, it should be bonded with sulfur, not either with a hydrogen or oxygen. Very much important. These are the common mistakes we make. So now what you can write, you will be having C, you will be having C, you will be having O minus. So now this is your nucleophile where you will be having SO3 H. Getting my point? Very much important. But do remember now here what happens, proton transfer takes place. What is happening? Proton transfer. That means what? Whatever the hydrogen part was there, that is now attracted by this alkoxide ion. So now here you just see, very much important, here now you will be getting as a SO3 minus, this H has come over here. So now you will be having over here as a OH. But this doesn't stops over here. Whatever the Na plus system is there, which has been in the system, it is now attracted by your sulfite ion, which will be giving you the final product SO3 Na and an OH. Very much important ಅಲ್ವಾ. ಹೈಡ್ರೋಜನ್ ಸೈನೈಡ್ ಅಷ್ಟು ಕಾಂಪ್ಲೆಕ್ಸ್ ಇರಲಿಲ್ಲ, ಡೈರೆಕ್ಟ್ ಆಗಿ ನಮಗೆ CN ಬಂದು ಕೂತ್ ಬಿಡ್ತು, ಅದೇನ್ ಮಾಡ್ತು H ಪ್ಲಸ್ ನಿಮ್ಮ ರಿಯಾಕ್ಷನ್ ಸಿಸ್ಟಮ್ ಇಂದನೇ ತಗೋಬಿಡ್ತು. ಆದ್ರೆ ಸೋಡಿಯಂ ಬೈಸಲ್ಫೈಟ್ ಅಲ್ಲಿ ಏನಾಗ್ತಾ ಉಂಟು, ಅಫ್ಕೋರ್ಸ್ SO3 H ಬಂದಿತ್ತು, ಆದ್ರೆ ಆಲ್ಕಾಕ್ಸೈಡ್ ಅಯಾನು ಸಿಸ್ಟಮ್ ಈಗ H ಪ್ಲಸ್ ಅಂತ ತಗೊಂತಲ್ಲ, ಇನ್ಸ್ಟೆಡ್ ಏನ್ ಮಾಡ್ತುಂಟು ಈ H ನೇ ತನ್ನ ಕಡೆ ಕಳ್ಕೊಂತ ಉಂಟು. ಅವಾಗ ಏನಾಯ್ತು, SO3 ಮೈನಸ್ ಬಂತು. ಈ ಮೈನಸ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಕ್ಕೆ ಅಫ್ಕೋರ್ಸ್ ಈಗ ಏನಾಗಿದೆ, NaHSO3 ಅಲ್ಲಿ Na ಪ್ಲಸ್ ಇತ್ತಲ್ವಾ, ಅದು ಹೋಗಿ ನಿಮ್ಮ SO3 ಜೊತೆ ಕುತ್ಕೊಳ್ಳುತ್ತೆ. So this is now your white crystalline PPT. White crystalline PPT. Very much important. ಈಗ ನಮ್ಮ ಪಾರ್ಟಿಗೆ ಬರೋಣ. ಏನ್ ಫಸ್ಟ್ ಅಂದೆ, ಮೋಸ್ಟ್ ಆಲ್ಡಿಹೈಡ್ಸ್ ಅಂಡ್ ಫ್ಯೂ ಕೀಟೋನ್ಸ್ ಅಂತ ಹೇಳಿದೆ. ಯಾಕೆ ಹಂಗೆ ಹೇಳಿದೆ ಅಂದ್ರೆ, ರಿಮೆಂಬರ್ ಆಲ್ಡಿಹೈಡ್ಸ್ ಸ್ಟಿರಿಕ್ ಹಿಂಡ್ರೆನ್ಸ್ ಕಮ್ಮಿ ಇರೋ ಕಾರಣದಿಂದ ಈ ರಿಯಾಕ್ಷನ್ ಬೇಗನೆ ಆಗ್ಬಿಡುತ್ತೆ. ಅಂದ್ರೆ ಅರ್ಥ ಏನು, ಏನ್ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ಕಂಡೀಷನ್ ಉಂಟು, ಇಟ್ ವಿಲ್ ಮೋರ್ ಬಿ ಟುವರ್ಡ್ಸ್ ದಿ ರೈಟ್ ಹ್ಯಾಂಡ್ ಸೈಡ್, ಅತಿ ಬೇಗವಾಗಿ ನಮಗೆ ಫೈನಲ್ ಪ್ರಾಡಕ್ಟ್ ಬರೋಕ್ಕೆ ಚಾನ್ಸಸ್ ಉಂಟು. ಕೀಟೋನ್ಸ್ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸ್ಟಿರಿಕ್ ಹಿಂಡ್ರೆನ್ಸ್ ಸ್ಟಿರಿಕ್ ಹಿಂಡ್ರೆನ್ಸ್ ಜಾಸ್ತಿ ಇರೋ ಕಾರಣದಿಂದ ಕೀಟೋನ್ಸ್ ಅಲ್ಲಿ ಈ ಇಕ್ವಿಲಿಬ್ರಿಯಂ ನಾವು ಈ ರೀತಿ ಬರೀತೀವಿ. ನಾಟ್ ಫಾರ್ ದಿಸ್ ಒನ್, ದಿಸ್ ಪಾರ್ಟ್ ಇದನ್ನ ತೋರಿಸ್ತೀನಿ, ಇಲ್ಲಿ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡ್ತೀನಿ ಇನ್ ಕೇಸ್ ಇಫ್ ಇಟ್ ವಾಸ್ ಅ ಕೀಟೋನ್ಸ್. ಲೆಫ್ಟ್ ಹ್ಯಾಂಡಲ್ ಕಮ್ಮಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ರೈಟ್ ಹ್ಯಾಂಡಲ್ ಕಮ್ಮಿ. ಹಾಗಾದ್ರೆ ಅರ್ಥ ಏನು, ವಾಪಸ್ ಅದು ಕಾರ್ಬೋನಿಲ್ ಗ್ರೂಪ್ ಕೊಡಕ್ಕೆ ಇಷ್ಟಪಡುತ್ತೆ ವಿನಃ ನಿಮ್ಗೆ ಕ್ರಿಸ್ಟಲೈನ್ ಪ್ರಾಡಕ್ಟ್ ಕೊಡಕ್ಕೆ ಇಷ್ಟಪಡೋದಿಲ್ಲ. ಯಾವಾಗ, when the ketones are bulkier, you'll come to know when I give certain examples over them. Okay, so that is the reason I use the word as most aldehydes, few ketones. Only some of the ketones which are smaller ketones, they will be giving you this type of addition product, but not all the ketones. But in major cases, all type of aldehydes will give this product, since the steric hindrance is less in aldehydes. Is that clear? Let's go with certain examples. The same examples, let me take acetaldehyde, CH3, C double bond O and a H. What happens when you treat this one with the NaHSO3? Of course, CH3 will be there, C will be there, this O has been converted to OH. Remember, here comes what? SO3Na. So, SO3Na, and here you will be having your H. So, what it is called as So this is your acetaldehyde bisulfite. So this is called as what? Acetaldehyde bisulfite. Mark my words. Bisulfite. P-H-I-T-E. Alva. Let me write it over here. So SO4 2 minus is what? Sulfate. Okay. S2 minus is what? Sulfide. S-U-L-P-H-I-D-E. Sulfide. Whereas SO3 2 minus is sulfite. Again and again I am saying, of course we have dealt with in our first PUC also. Once again I am reminding you, don't get confused. We are using this part, sodium bisulfite. So SO3 2 minus. So that is the reason SO3 N. Is that clear? I hope no doubt. Clear? So whenever your acetaldehyde is treated with sodium bisulfite, you can just see you're getting an acetaldehyde bisulfite. Don't get confused. Don't try it as SO thrice H. The final product is having SO thrice Na as a nucleophile. Is that clear? Let me take now acetone. CH3, C double bond O and a CH3. When it is treated with your sodium bisulfite, can you write the product along with me? Okay, take a book and a pen. Write it now. CH3, C, OH, SO3, Na and a CH3. So this is called as what? Acetone bisulfite. Acetone bisulfite. Remember, one of the most important reaction, because this reaction is useful in the purification of our aldehydes. Purification and separation of our aldehydes. What is the main reason, Andre? So the hydrogen sulfide addition compound, whatever you have got over here, this product can be converted back to respective aldehydes. Okay, this is the ketone, alva. So this product, whatever the addition bisulfide product you have got, this can be easily converted to aldehyde by treating with your mineral acids. For example, it could be a dilute mineral acid like dilute H2SO4, dilute HCl. So that is the main reason this part is used for the purification and that of your, what you can say, separation of aldehydes. So remember, once again, if you take this product, that is your addition product, whatever you got, and you're going to treat this with some dilute acids, dilute H2SO4 or dilute that of your HCl, it will take a proton and once again it will be giving you the respective aldehyde. So that is the reason we can easily convert it or we can easily separate it from aldehydes and ketones. Okay. As I mentioned, remember your benzophenone, then what you can say, any other ketones you are knowing? Yeah. Diethyl ketone and acetophenone, benzophenone, acetophenone, if I take diethyl ketone, benzophenone, acetophenone. So remember, these are the ketones which will not undergo nucleophilic addition reaction with sodium bisulfite. Only reason is because of the steric hindrance. That is the reason I said only few ketones which are very small, which are not having much bulkier groups, they can easily undergo this addition reactions, but not that of your benzophenone, diethyl ketone and acetophenone. So what are the two important things we have come to know with respect to the treatment of your carbonyl compounds with that of your sodium bisulfite? Remember, aldehydes easily undergo the nucleophilic addition reaction with that of your sodium bisulfite, but ketones not. More particularly when I talk about ketones, your benzophenone, diethyl ketone, acetophenone will not at all undergo your nucleophilic addition reaction with sodium bisulfite. Is that clear? Very much important to note all these points. Okay. So whatever I have said is an additional information, but this reaction is very much important both in the point of your exams and also for your point of your competitive exams. And important, remember, whenever we are treating an addition product of your sodium bisulfite with the dilute acids, once again it will give you the aldehyde. ಯಾಕೆ ನೋಡಬಹುದಲ್ವಾ ಇಲ್ಲೇನ್ ಪ್ರೋಟಾನ್ ಟ್ರಾನ್ಸ್ಫರ್ ಆಗಿ ನಿಮಗೆ ಮುಂದೆ ಹೋಗಿತ್ತು ಅಲ್ವಾ, ಅದೇ ಪ್ರೋಟಾನ್ ನ ಕೊಡ್ತೀನಿ, ಅವಾಗ ಏನಾಗುತ್ತೆ, ಈಕ್ವಿಲಿಬ್ರಿಯಂ ಅಲ್ಲ ವಾಪಸ್ ಬ್ಯಾಕ್ ಹೋಗಿ ನಿಮ್ಗೆ ಏನ್ ಕೊಡುತ್ತೆ, ನಿಮ್ಮ ಕಾರ್ಬೋನಿಲ್ ಕಾಂಪೌಂಡ್ ನೇ ವಾಪಸ್ ಕೊಡುತ್ತೆ. ಆ ರೀಸನ್ ಇಂದಾನೆ ಹೇಳ್ತಾ ಇರೋದು. ಇದಕ್ಕೆ ಮಾತ್ರ ಸಾಧ್ಯ when you are using dilute acids. Okay, so whenever an addition product, whatever you have got, is treated with that of your dilute mineral acids, it will be giving you back your original carbonyl compound. Is that clear? No doubts. So this completes of today's video of nucleophilic addition reaction with respect to your hydrogen cyanide and sodium bisulfite. Okay, so in our next class or our next video, we are going to see the other two important nucleophilic addition reaction, that is with alcohol and with the Grignard reagents. Okay.